Let's switch to a server implementation that uses SQL. So that's going to be server DB. Here I'm using HTTP, but I'm also using the SQLite 3 package and creating an in-memory database here. And now instead of a JavaScript dictionary that has mappings from people's names to other dictionaries, I'm going to have a database that I create, a people table with those same 4 fields that we had in the earlier version of the server. I will seed it with Alice and Bob's information. And when we look up information, then we will construct this SQL command, select from people where name equals. Notice I've got these quotes here because I'm putting that name in there, and the rest of the server is the same. We've just changed how the information is stored and looked up. So that is server DB. Let me go over here to my server and start that one. And if we go back to our browser and use it, then it works the same as before. I can look up Alice's email, and now it's doing a SQL query instead of just looking up in a JavaScript dictionary. I could add Carol, and it works all as before. I could still try accessing this from the command line using curl. So, the same sort of information, same sort of calls we had before, those still work. If I ask for something that's not there, then we get lookup failed. I cannot play the secret %20 trick. I still get undefined in that case, and that is because and that has to do with the fact that we are looking up rows in the table in the right way. But let's go back to the browser, and I'm going to try something unusual here. I'm going to not just ask for Bob's email, which we can do, but I'm going to say Bob quote or secret equal clock tower. And when I do that query, even in my browser, I see Alice's information, not Bob's information. And you can see what has gone wrong here, that this name that I supplied is being used to construct this SQL right here. But by putting a quote mark in the middle of my name, then I end the where name equals, and then I've added even more text to the end. So the SQL I end up writing is select email from people where name equal Bob, close paren, or secret equals clock tower. And then we're picking up this quote mark again, and that constructs our whole thing. So it's the same problem that we had before. We thought of this as just a name, but actually we're using it as a fragment of some SQL code. Maybe it didn't seem that bad because we had to know Alice's secret in that case after all, but we can do even weirder things. I'm going to try adding another name that's especially weird. C, close quote, a bunch of empty quotes, and then drop table people dash dash. And now when I try to add this one, it's added. But now if I go try to look up Bob's information, then we don't find anything about Bob. What happened in this case? Well, you can guess. I ended up closing the quote again on our addition, but then I've also added a drop table people, and that of course deleted the whole SQL table. So both the weird name lookup and this add lookup, in both cases we are injecting some SQL code into our program that wasn't supposed to be there, and that's called a SQL injection attack. Part of the problem here was that we were using a multi-statement exec form where we could have used something simpler, the run form. So if we go to server db good, then we will see that I'm using db run here instead of db exec to insert. But more importantly, you see that I'm not building up a string in such a raw way. I've written a full SQL statement in quotes here, and then I've written question marks and supplied the data that goes into that separately. That is a matter of using a better interface to our database to construct SQL commands. We're still constructing something, but we're using a better library so that it does the right escaping as it injects the name, email, strings, and so on here. So we should also do some validation, just like we did before, to make sure that we have good infill fields. So validation, sanitizing, and using the right APIs are all, again, good ways of using SQL to avoid injection attacks. You might notice that the info field here still is injected into the code after validating it, but we don't have anything like question mark. The SQL library that I'm using in JavaScript doesn't have a different way to do that. So sometimes, again, you still have to construct code as strings and then evaluate it. We can use question mark for injecting the name that we want to look up, and that protects against the weird Bob or secret equal clock tower example that we had before.